Hi guys. Today I want to talk about the myth that the optimal fat burning zone is considered uh, really low intensity exercise or walking pace or a recovery pace, if you will, zone one on a bicycle. Um, and let me show you the reason why. If you look at this table, you'll see that you have an R value on the left, percent fat, percent carbohydrates. What this basically says is that at an R value of 0.7, we're metabolizing 100% fat. At 1.0, we're 100% carbohydrates. Well, in truth be told, there's never a point while we're exercising or actually even sleeping that we're metabolizing 100% fat. It's always going to be either a mixture of fat or 100% a mixture of fat and carbohydrates or 100% carbohydrates. And so even at the lowest intensity pace, whether that be a walk or a zone one effort on a bicycle, you're still going to be burning some carbohydrates. As much as probably in terms of percentage, if you're really cruising on a bike, maybe 75% fat and 25% carbohydrates on a cruise. Probably like somewhere in here, 0.77 or 78. Well, what that would say is that the lower the intensity, the exercise, the higher the percentage of fat, and therefore that's where we should be exercising if we want to burn as much fat as possible. But it's a misrepresentation because when you're talking about how much fat you want to burn, it's the total amount of fat and not the percentage what is most important. And so let me explain why. So if you look at this graph, I'm asking the question, what's the best steady state intensity? And I put best because what's your idea of best? I have in quotations and burning. It's, we're talking about, metabolizing fat, using fat for fuel for powering muscular contractions and movement and so forth. But anyways, so I'm asking what's the best steady state intensity? Um, Low, 20% VO2 max, moderate pace, 50%, or high, 80% plus. And I gave a nice range of values. And, a lot of people, based upon that previous table that I showed, would answer that a low intensity would be quote unquote best. Um, However, that's not really the case. And that if you look here at this chart, this table that I created, you'll see a range of exercise intensities that go from 30% VO2 max to 100% VO2 max. We're not really, when you get on a bike and you start pedaling, it's actually quite difficult to exercise at an intensity that's really much less than 30%, because even sitting down, not exercising, you're and just existing, um, you know, uh, you're probably in the 10% VO2 max area as far as oxygen consumption. So you're never at 0% VO2 max, never at 0% oxygen consumption because well, you'd be dead. So these are a reflection of really good exercise intensities that range from zone one to maximal at 100% exercise intensity. So remember from that chart that the lower the exercise intensity, the greater percentage of, of fat that we burn. And if you look here, 30% VO2 max exercise intensity, 100% VO2 max intensity, you'll see that's also reflected here. Percent of calories from fat, the highest percent, right, and that's 54%, zero in decimal form, comes from at 30% VO2 max. 54% of the calories in this individual is burned from fat at 30% VO2 max. And you'll see in the percentage drops. At 40%, it's 47% fat. At 50%, 40%, so on and so forth. 60% VO2 max, 33%, all the way down to where it drops off to pretty much nothing, right? Which was where we're burning almost entirely carbohydrates. So you would expect, or most people want you to believe that this is the best fat burning zone or the lowest exercise intensity. But if you look at the C column here that I created in terms of total fat, it's not the case. Actually, the 50 to 60% VO2 max is where total fat oxidation actually peaks. You'll see that? A greater quantity than at the lower exercise intensities. So why is that? And that's because our metabolic rate increases dramatically over the exercise intensities. So as our metabolic rate increases, we're burning vastly more calories in total than we were at the lower exercise intensities. And so therefore, the fact that we're burning more calories in total, vastly more calories in total, the percentage that comes from fat is not as great of an influence. For example, you'll see that 33% of 9 calories per minute, or metabolism of 9 calories per minute, is a greater number than 54% of 4.5. All right? What this tells you is that the metabolic rate, all right, or increases so much as exercise intensity goes up that even though percentage is slightly in favor of low calorie or low intensity exercise, the metabolic rate greatly makes up for that and overwhelms it into the fact that moderate intensity exercise is the best in terms of burning total amounts of fat. And you could just do, I tell you right now, so, let's say your metabolic rate is 10, and at 10 you're burning 30% fat. That means 3, right? 30% of 10 is 3. And let's say your metabolic rate is 4, right? And you're burning 50%, which is a higher percentage, at 4. Well, that's only 2, so 3 is the greater number. So in essence, what the take-home message here is that the metabolic rate more than makes up for the percentage of calories that you're using from fat, and that the best in terms of total fat metabolism happens in the intermediate or moderate exercise intensities. In this case, this individual, 50 to 60. However, here's the good news. For trained individuals, they can push their maximum fat oxidation rates up even higher than 50 or 60. They can push it up to probably close to 80% of their VO2 max. And the reason is your lactate threshold. Your lactate threshold is the point at which lactate accumulates in the blood, and it also correlates with levels of blood acidity. All right, and that when your blood becomes too acidic, it actually hampers the breakdown of fat from your adipose tissue, and less fat gets dumped into your blood, and therefore less fatty acids are delivered to your muscles to be burned. All right, so what happens is that when you go beyond your lactate threshold and acidity gets too great, fat breakdown slows down, and there's less fat available from your bloodstream for your muscles to use. So that's why raising your lactate threshold, right, is also conducive to burning fat, because you can burn it at higher intensities. So your metabolic rate will be higher and your total fat will be higher, because you will still be releasing a lot of fat from your adipose tissue. Your blood will still be delivering a lot of fat from your adipose tissue, and therefore it will in turn be burned. So look at this. Intensity and availability dictates fuel source proportion, but not total amount. All right? And that as intensity of exercise increases, we continue to use more and more carbohydrates. But availability also dictates fuel source proportion. and that once you cross your lactate threshold, the availability of fat declines greatly. And therefore, not only because the metabolic rate, it's easier to burn carbohydrates at high exercise intensities. In fact, it's more efficient. But also the fact that there's less fat availability means that we will utilize less fat. And so this particular individual, 50 to 60% of their VO2 max, this person's likely not highly trained. You'll see their VO2 max, the estimate of their VO2 max was 240 watts. And so that's about their VO2 max wattage is something they can maintain for about 8 minutes. So not too elite. So what you find, again, with trained individuals is that their lactate thresholds will be higher. So this individual is probably, around the 60%, his lactate threshold, maybe a little bit higher. And that's why you see it start to drop off at 70. But those with lactate thresholds that are, as high as 80% means that this number is going to keep climbing, right, until you get to 80%, and you can burn lots of fat. So that's how lactate threshold correlates with fat metabolism, and that, it goes beyond just your ability to sustain high intensity performance, but it also has an impact on how much fat you can burn. And FYI, for those of you who think that your lactate threshold is your FTP or what's called your maximum lactate steady state, the lactate threshold actually occurs, or the LT1, not LT2, occurs for trained athletes in the tempo zone, not zone 4. All right, typically, highly trained athletes can maintain an intensity that is above their lactate threshold for an hour, all right, or your FTP. So I hope you learned something about burning fat and the best exercise intensity to burn the greatest total amount of fat and not just percentage. I will talk to you guys later in my next episode of Exercise Physiology. Take care.